We are going now to present 4 assignments that you have to do before a specific deadline, which is mentioned on the portal. These 4 assignments must be done in 4 different GAMS files, and you do the first exercise following the order, and once done you copy it in a second file, and you include the modifications that is explained in the second exercise, and so on. Get to work as soon as possible because there is a lot of work, and don't hesitate to ask us for help. We are here to help you, so do not hesitate, and good luck with that. We now ask you to do a first exercise. So this exercise is based on the model that we have just presented. We ask you to program this model in GAMS language in a specific file. And I remind you that this is a model describing the rice sector in Senegal. So what is the object of this study? This is the study of an impact of a trade policy reform, which consists in a 20% custom duty on rice imports. And so you have to study the impact of this policy on consumer surplus, producers surplus, and public revenue. So you remember the concept of surplus. So the surplus is a concept taught in the first year of economics at university. If you do not remember this concept, you can consult a PDF file available on the site. The last question that we ask is, should the government make the decision to implement this tariff if national well-being is defined as the sum of these 3 terms: producer surplus, consumer surplus, and public revenue? So you need some data to feed the model. Here are these data. So these are initial data for the model. So first, the initial custom tariff, which is T, which is equal to 0. Then data from the website of the Food and Agricultural Organization, FAO-Stat. So first, the world price of rice. It is expressed in dollars. Then the local supply in Senegal of rice in tons, and then the local consumption of rice also expressed in tons. So I also show you some value for the parameters B and D. So these are the slopes of respectively the supply function and the demand function. And so these slopes have been calculated to reflect local elasticities, which are equivalent to elasticities calculated in an academic article from Combaté, Kofi Tessiu, and Diane in 2010. So you've got here first B, which is the slope of the supply function, then D, which is the slope of the demand function. So here is the second assignment, and so in this second assignment you start with the previous model obtained at the end of the first assignment, and I propose that you change the linear functional forms into isoelastic functional forms. So I think this is an interesting exercise, in particular because you will have to think about functional forms, and also because you have to think about calibration. So you have to give up the functional form P is equal to A multiplied by XS plus B for the supply function, and you have to change it for an isoelastic functional form, which is expressed by XS equal to A multiplied by P at the power B. And so this functional form is really interesting because it's very usual in the network of CGE modelers. Why? This is because, in fact, elasticity is constant, and so you have to estimate with econometrics only one parameter, which is b, because we can in fact show that b is equal to dxs over dp multiplied by p over xs. So this is the elasticity of supply with respect to price. And I propose here that this elasticity equal to 0.05. So of course you have to think about the calibration. You have to change the calibration of the model. Let us consider now the demand function. So in the previous assignment, you've got a linear demand function, p equal to minus c multiplied by xd plus d. So you have to give up this functional form and change it for an isoelastic form expressed as xd is equal to c multiplied by p at the power minus d. And so same remark as for the supply function. We can demonstrate that d is equal to minus dxd over dp multiplied by p over xd. And I ask you to put this parameter here at 0.4, which is the elasticity of the demand function with respect to local price. And of course, you have to change the calibration. So let me now present the third assignment. So this is about the introduction of a market power by Senegal. That is to say, we assume now that Senegal, when import demand changes, the world price is going to change. So Senegal has a market power. Of course, you may think that Senegal is a small country, but what we can do here is to introduce a market power which is only limited. So it means that you remember that in the previous design of the model, the world price was constant. So we give up this assumption, and now when the demand for imports by Senegal is changed, it has an impact on the world price. And in particular, when Senegal increases its demand for imports, it increases the world price. What we can explain here, and maybe this is a more precise explanation, is that, you've got an increase in the demand by Senegal for imports, and if you want to have an increase in the supply of imports by the rest of the world to Senegal, well, it can happen only if there is an increase in the world price of rice in order to give a better price for the producer of the rest of the world. And of course, we have to design an effect which is limited. So I'm going to give you a few indications to make this assignment. First, we keep 5 equations from the previous model. So there is only one equation which is changed. This is the equation PE is equal to PE0. That is to say, the world price is constant. So it's easy to understand this point. So you give up this equation and you change it for a supply function from the rest of the world, a supply of imports of rice from the rest of the world. So it is the quantity of rice that the rest of the world is willing to export to Senegal. Okay, and this is an isoelastic functional form. So it's, for example, ms equal to f times pe at the power e. So it's a positive, an increasing relation between the supply of imports by the rest of the world to Senegal and the world price. So it's exactly the kind of relation that we just explained in the previous slide, and I ask you to put E at a value of 60. Why? Because if you've got a certain variations in the quantity of imports, well, with such an elasticity, you will have only a small variation in the world price. Okay, so let me now present the fourth assignment, which consists in the introduction of a second good. So how do we design a model with two goods? Let me make a preliminary remark. It's very easy from the design of this model with two goods to make a generalization and to design a model with n goods instead of two. So there are different options concerning the relationship between the two goods. First, we can consider demand for substitutes. So for example, it's rice and it's another cereal, which is a substitute to rice. Okay, so the second option would be a demand for complements. For example, we can consider demand for coffee and demand for sugar. And the third option is to consider that one good is input to the other one. So, for example, you have plastic, steel, and a car. Okay, so you've got different options here, and of course, the last case you can have n stages in the value chain, and you have a very generalized model with at each stage substitutes for each good. Okay, so what we are going to do here is to consider the first case where consumers buy two substitutes. Okay, and what we will consider is a very simple case where you've got local rice, okay, and foreign rice, which is different varieties. Okay, so these are two varieties, okay, and they are substitutes. And of course, it's a more or less realistic case in the Senegal framework, because in Senegal, in fact, you have one imported variety and several local varieties. So let me now give you a few indications for this fourth assignment. So you understand that in Senegal there are farmers cultivating rice and so offering this good on the local market. At the same time, Senegal imports rice from the rest of the world, and it's a different variety. So in fact, there are two varieties of the same good, so two goods, and there are two prices for the foreign rice, which is imported in Senegal. First, there is the world price, which I call PE, and then there is the local price of imported rice, PM, and so there is a gap between the world price and the local price of this good. So this is the same good, and so the difference is, for example, the import duty. Second, there is the local rice, which is the other variety, and there is one price for the local rice, which is P. So let's focus now on the equations of the model. So there are a few equations that we must keep, because they are still relevant for the model, even with two goods, and there are of course some equations that we have to change, and in particular these are the equations of demand. Why? Because in fact there are two goods in consumption, and there are substitutes, and so it means that the demand of one good depends on the price of this good, but also on the price of the substitute. So for example, you've got the demand for local variety, which must depend on the local price of the local variety, and the local price of the imported variety. Because of course the imported variety is substitute of the local variety. So it means that you cannot keep the previous form, which implies that demand for local variety only depends on the price of this variety. And of course you have also to change the demand for imports. Okay. The previous form implied that it's only a definition in terms of excess demand, but right now it has to change because the demand for imports depend on the price, the local price of the imported variety, okay, but also the local price of the local variety, which is a substitute to the foreign variety. So you have to change these two equations. So here I write the demand function under a general form. So I call D demand, and demand for a specific good is a function of the price of this good, P, and the price of the substitute, which is P prime. So what is the form of the relation between P and D? That is to say, between a demand of a specific good and the price of this good, it is a decreasing function, which is something that we have already used and shown. And so we've got this decreasing relation. What is the form of the relation between D and the price of the substitute? It's an increasing relation. Why? Because in fact, when P prime is increased, so consumers are less interested by the substitute, and so they are more interested by the consumptions of the first good. So when P prime increases, D increases. And of course, you have to implement this relation under an isoelastic functional form. I just want here to illustrate what I have just explained with a graph. So it's a graph describing the adjustment of supply and demand of the local variety. So with quantity on the horizontal axis and the price of the local variety on the vertical axis. So on the horizontal axis, it's quantity of demand for the local variety. And of course, you've got supply, which is still increasing with price. Okay, this is supply of the local variety. And you've got local demand for local variety, which is decreasing with price. And so the intersection of demand and supply gives you the equilibrium price and the equilibrium quantity. So what I just want to illustrate here is what happens when the price of the foreign variety is increased. In fact, there is a translation of the demand functions on the right. So why? This is because in fact local consumers, they are less interested by the foreign variety because the price of this variety is increased, and so they turn on the consumption, partly on the consumption of the local variety. And so it means for any price of the local variety, the local demand is more important. Okay, and so the new equilibrium price and the new equilibrium quantity for the local variety is higher. Okay, and so we've got here an illustrations of what happens when the price of the imported variety is increased. So it remains the initial data to calibrate the model. So you've got here the initial import duty, which is equal to 0. So import duty on foreign rice implemented by Senegal. Then data from FAO Stat with initially the local price of the local variety, which is in US dollar. So it's the price of a ton of rice. Its P0 is equal to 590 US dollar per ton. And then the world price of the rice which is imported by Senegal, which is which is in a ton, in US dollar per ton, and so it is PE0 is equal to 570 US dollar per ton. And then you've got the initial local supply, which is 726,000 tons of supply of local rice. And then you have the demand for imports, which is also in ton, and which is 6,830,683 tons. Okay, so here are the elasticities which are necessary for the calibrations of the model. So they come from a review of literature. Of course, it's better if you conduct your own econometric estimation of these elasticities. But here we do not have enough time, so I give you these elasticities. So B is elasticity of local supply to local price. B is equal to 1.5. D is equal to the elasticity of local demand to local price. So D is equal to 1.02. And you've got DM. DM is the elasticity of import demand with respect to local price of imports. So DM is equal to 1.02. And here, as you have substitutes, and so demand depends on price and price of the substitute. You've got two cross price elasticities. First, EDM. EDM is the cross elasticity of demand for local rice with respect to local price of imported rice. So EDM is equal to 0.96. And EMD. EMD is the cross elasticity of demand for imported rice with respect to local price of local rice. EMD is equal to 0.96. And you've got also E. So E is the elasticity of foreign supply of imports with respect to world price. So it doesn't change as compared to the previous assignment, and E is still equal to 60.